Welcome to the project demonstration of battery management system and SOC development for electrical vehicles. So here we are going to monitor the battery voltage along with SOC calculations, and also whenever the battery temperature increases threshold value, then with the help of this temperature sensor we are going to measure that and provide us the audible alert through the buzzer. So here the main features like checking the voltage and along with the SOC SOH calculations and also temperature. So these parameters continuously monitoring on the OLED display which was interfaced to this ESP32. So using ESP32 we are continuously monitoring these voltages from this voltage sensor which is potential divider 10:1 potential divider ratio, which will take 12 volts DC input and provide us the 1.2 volts DC output, as we are using the 1:10 potential divider for voltage dividing purpose, as ESP32 can handle up to maximum of 5 volts. So for that we are going to use the potential divider to reduce the voltage. And in the ESP32 we write the program to multiply the input voltage which is getting from this voltage sensor will be multiplied by 10, so that we are getting the same battery voltage will be displayed on this OLED, as well as temperature from this temperature sensor. And when it crosses the 40 degrees centigrade, then the system will provide us the audible alert through this buzzer board. And also if the voltage of this battery pack is less than 8 volts, then this relay used to getting power supply to this battery pack for charging purpose. So this relay will be getting on and off by this ESP32 whenever the battery voltage is less than 8 volts, and the relay will get switched on, and whenever it is more than 10 volts, then the relay will be getting switched off. Coming to this battery pack, we are using 3 batteries, each battery of 3.7 volts of battery with 1200 mAh of 2600 mAh of current can be getting from this battery pack. Totally 11.1 volt total output from this battery pack, which is rechargeable through this charging circuit. So your main power source is 230 volts input to the system that will be parallelly distributed to the transformer which is used to charging of the battery pack through this regulated power supply board, and parallel to this regulated power supply board which will take 230 volts AC input and provide us the 5 volts DC output, so which is a main power source to the system. That's why we are connecting the 5 volts at this breadboard. From there we are distributing the 5 volts throughout the input output modules, and output of this transformer is 12 volts of AC that will be converted into pulsating DC with the help of this rectifier, and from DC is the input to this battery pack through this relay board. And these 2 diodes will act as a unidirectional current flow. Whenever the battery is getting full charge, then the reverse current will be blocked with the help of these diodes, and LED indicator will show the availability of power from this charging circuits. So once again, all of the components, let me explain that. 230 volts AC input to this RPS board, transformer, from there to the charging circuits, from there to the battery pack through this electromagnetic relay, and output of this RPS board is input to this breadboard. From there we are distributing that throughout the input output modules and ESP32 module, OLED display, temperature sensor, buzzer board, voltage sensor, and battery pack. So let us see the demonstration. So on the power supply, then wait till the welcome message displayed on this OLED board, right? And after that the voltage of the battery pack is continuously monitored, and temperature SOC SOH. So SOC SOH will be calculated after 10-15 seconds of duration. Then the system will get the SOC SOH values. Right, we got the SOC SOH values. SOC nothing but state of charging, means whenever the battery voltage is recorded as 11.1 volt, maximum it can charge up to 12 volts. So it will take the reference of the 12 volts. So if the battery voltage is kept as sufficient, then the SOC value will be reached to the near to 100%. If the battery drastically discharged or rapidly discharged or is not charging properly when the charger is getting on, these 2 values will affect the SOC and SOH. So just to make the low battery alert, we are disconnecting the battery to the voltage sensor so that we'll get a 0 volts. Then parallelly the system will on this relay to provide the power supply to the charger. So whenever while demonstrating the project, if you have the low battery voltage, just to charge that, disconnect this and keep the kit on, then automatically the battery will be charged. And coming to the temperature, so just we are using the external heater to heat up this temperature sensor. So as we can see, the temperature increases, right? sorry, here we set the temperature value of 50 degrees centigrade. So whenever the battery pack temperature is crosses 50 degrees, then we will get the audible alert to the buzzer as alert of temperature of the battery pack increased due to the reason of over voltage or overload on this one, or any short circuit occurred in the circuit. Right. Thank you.